So now how much is 1 gigabyte? It's actually not much at all. For example, if you watch 15 minutes of medium quality YouTube, not HD style, every day, then after a month, even if you do nothing else at all on your wonderful iPhone, iPad, Galaxy, Android tablet, then that is 1 gigabyte a month. Another way to look at a gigabyte is that you get to watch half of a medium quality movie or TV movie, let's say. Okay, so if you want to watch one high quality movie, you're going to pay $50. Now, $50 for one movie on your laptop is kind of expensive. So now the question is, what can we do? Okay. Now, what are the driving forces behind the increase of demand? The fact that demand for bandwidth, including bandwidth on mobile cellular data networks. There are quite a few. One is the device features and the resolution. Thanks to Steve Jobs and iPhone 1, the first iPhone back in 2007, announced with AT&T in the US. Within a month, AT&T saw over 50 times increase in their mobile data demand. Before 2007, you have devices that can help you go online and a mobile device, but the usage was very low. But iPhone's features, iPhone's design, tempted people to dramatically increase their mobile data usage. And the resolution keeps getting better, okay, into HD, into Retina display, multiple times of HD resolution, and onto an iPad. So that's number one driver. Number two driver is that it gets better and better with the speed. Okay, on 3G networks, as we will see later in lecture 19, when we talk about the actual speed you can expect for applications on mobile devices. We know that for 3G, the actual application layer speed is not that great. That's why a lot of times if you go to an app store, if they don't think you're on a Wi-Fi device, they don't even start downloading the app. You can try movie, you can try a big PowerPoint download. You will see that the speed is sometimes unbearably slow. But with LTE, that's being rolled out in the US and other parts of the world in the coming month, you will see that the speed is significantly improved. So you can actually watch movie on the go now. Okay? And the better the speed, the better your experience, and more tempted you are to use your mobile data plan. Number three is the video domination. Later in lecture 17, we have a whole lecture talking about video distribution. But it suffices to say that video is, by volume, the dominant force. Some estimates say 65%, some say 80%. Somewhere in that range is all kinds of video applications. The fourth one is coming up the cloud services. We've already seen a lot of cloud services. Later in lecture I think 16, we will devote a whole lecture on cloud services. So in some sense, the slide is a quick preview of quite a few later lectures in the second half of this course. And whether it's a Dropbox or other kind of cloud software, or whether that is a cloud-based music streaming, they can incur a lot of data usage. Maybe not as big as video, but still quite a lot. And finally, out of maybe 500,000 apps out there on iOS and Android devices, increasing number of them are capacity hungry. Okay, so use a lot of capacity in real time. Across the board, much better device, much higher speed, together with the dominance of video, cloud, and capacity hungry apps, means one thing. They collectively imply that the demand curve over time goes up very sharply. So the impact of that trend, as we'll see, it matters where's the supply curves over here, and also the tail distribution of the usage behavior. But roughly speaking, this kind of exponential growth of demand is huge. Okay, it changes the pricing structure, as we'll see. At least in the US, mobile data market, the carriers, the internet service providers tried very hard for over a decade to resist going from flat rate to usage based. At some point, and that some point is this year, 2012. Okay, they say that's it. Okay. If I offer a buffet and the customer keep coming back with twice the appetite, then I have to stop at some point and start charging based on how much you actually eat. Okay. And this in turn has many impacts. First of all, impact to you and me. We are consumers of mobile data, and we have to pay the monthly bill. So another way to ask today's question is, how do I understand my monthly bill from my cellular carrier? It clearly has implications to carriers. Okay, whether it's AT&T and Verizon, by far the top two mobile carriers in the US, or some other carriers in other parts of the world. It has implications to the vendors, whether it's Ericsson or Alcatel or Qualcomm and Cisco, supplying to these carriers in various ways. It has implications to content and app providers, okay, whether that's studios or like ESPN, Disney, whether that is content providers like NBC and ABC and so on. Whether that's Netflix or YouTube or Hulu. Okay? Because if this $10 a gigabyte bends the curve of this demands over and start to make people hesitate before consuming mass amount of especially video content, then that rings a bell in content providers' radar screen. And this in turn has implications to advertisers. If the mobile consumption of certain content becomes bottlenecked by the pricing structure of data plan, then advertisers will feel less incentivized to pay for hefty advertising fee. So there is a lot of implications. And one way to draw the food chain of this industry is through this simple picture. Okay? Here's where you and me live. Okay, we are the consumers of contents and apps of various kinds. Then there are some distribution operators, for example, Akamai, Limelight. These are the top two content distribution providers. Okay. Later in lecture 17, we'll talk a little bit about content distribution providers. Then there's transportation operators like AT&T and Verizon Wireless for mobile, okay, and then for broadband wireline as well, including some cable providers like Comcast. And then there are content ad producers, okay, including those that are distributing contents like Netflix and YouTube, Hulu, and so on. Then there are vendors that supply devices and software to all of these segments in the food chain. Traditionally, the food chain goes in this way. Okay, content providers send it to transportation operator, who may rely on some distribution operators, who then go get the content to us. But now there's increasingly shortcuts. For example, the content providers say, you know what, I'll just go straight to distribution operators, or even go straight to the consumers. For example, I will just issue an app with my content. I may say that you don't need to subscribe to a particular TV program by these content broadband providers. Instead, you can just watch my content anywhere you want for my app. All you need is a data pipe. You do not need TV services. And later in lecture 18 or 17, we will have a lot more discussion on the dynamic, the changing mode of consuming video content today. Some transportation operators also bypass the distribution, go straight to the consumers. So this is a very interesting set of interactions across these 5 parties. And that adds a lot more complexity to our discussion. But let's pull ourselves back to the simple motivating question. Why flat rate? What's so good about flat rate? What made it so popular in the US mobile market for about 15 years, since 2G all the way to today, okay, or very recently? Well, first advantage is simple. Okay, not only is it simple to provide in terms of billing services, also simple to explain to the consumers. One cannot underestimate the importance of a simple user interface, including the message to the consumers. Number 2 is that because it's so simple, it's good for creating the market. Back in 95 and so on, when the internet just started in the broadband market, and then back in early 2000 to mid 2000 in the cellular 2G, 2.5G market, demand for the entire market was the number one concern. We want to make the demand as big as possible, make it increase as fast as possible. And furthermore, I want the demand for my company service, okay, if I'm a carrier, to be big. So I would like to find a way to capture market share, and a simple message with unlimited data is the way to go. But all these are feasible because there's underlying inequality. That is, the demand, both the absolute value and the growth projection of demand, was still in line with the supply per dollar of investment in both what's called capital expenditure, like buying wireless spectrum, laying down a fiber, buying equipment, as well as operational expenditure, okay, such as maintaining fleet, maintaining staff, running the billing records, and so on. Now, often for a carrier, the largest expenditure for wireline is digging trenches for CapEx, or short for capital expenditure. And for mobile, it's often buying the spectrum and the right-of-way to install the antennas. The operation expense often tends to be rolling a truck to service a customer complaint. Okay. So the CapEx and OpEx needs investment, and you want to make sure the investments has a return. The return is good enough. So you would like to look at the supply of capacity to support the demand for each dollar of investment. Both the value and the growth trajectory of demand versus supply per dollar sign for many years we were able to catch up demand through per dollar supply of capacity. So this was the underlying reason why it is feasible to engage in these ways of increasing overall demand and capturing my company's market share. So what became different? Okay, what happened in 2010 to 2012? Again, I'm all talking about the US market, especially US mobile 3G, 4G market, but a lot of the storylines also carry through to other countries. So what changed? Well, I have to actually go back to say what changed in 2007. That was the year that prompted the recent changes. It took always several years for the industry to make plans, run trials before executing a change. Okay? So the root of change was 2007 in the US mobile market. And what happened? Well, what happened was that Steve Jobs introduced the iPhone. Okay? A magical device. Not only it changed the software industry and computer industry, it changed the communication and networking industry forever. So iPhone increased demand, but more importantly, it twisted the shape of the demand curve projected over the years. So these are the years. Okay. So this is say 2007. This may be somewhere around 2010, 2012-ish. Okay. And the y-axis is the demand or capacity, say measured in gigabyte per user on average. The demand has always been growing and growing in a convex way. Okay, so the first derivative over time goes up, and the second derivative also goes up. It's increasing in convex curve, but now the first derivative is even bigger with the introduction of iPhone and the follow-ons. Okay. Now people look at this curve and say, gee, we're looking at many estimates assume basically doubling every year, and I think by many accounts this is actually an underestimate of growth rate of demand. So it's not just the demand today that matters, the trajectory you expect, you anticipate is the first derivative. Well, I'm doing many derivatives now. This is the first derivative of the demand curve over time, and that matters because you have to look at the projection over the next 5, 10, 20 years in order to make a lot of the investment and pricing decision today. So if you look down 5, 10 years, in fact, look down 2 years, you will see that this is a crazy growth curve in demand. In most industry, a crazy growth in demand is good. Okay. But that's assuming that you can catch up with the demand, and revenue, which say depends on demand, minus cost, that is the profit of a company, can also grow similarly to a demand. So can you maintain this difference to grow in the same way? Well, not if your supply per dollar investment is growing slower than the demand. So this is what happened. We had a critical shift in what we call the Jobs inequality of capacity in honor of Steve Jobs. That says the derivative of demand is projected to be much bigger than the derivative of supply. By supply, we mean supply per dollar of investment, of course. If you have unlimited dollar to spend, then sure, you don't worry about it. But for limited investment, say per unit, $1, $1 billion, what is the derivative of the supply curve growth? This first derivative is much bigger than this first derivative in the projected future. And therefore, we have to do something different, something other than buffet. Okay. A second curve to explain why change in 2010 to 2012 range is because of the long tail. Okay, if we look at the probability distribution of a usage, let's say this is the 50 percentile, that's the median user today. Okay, and by many estimate, the median user isn't that heavy actually. It's still under a gigabyte or less. Okay, 1 or less. But if you look at the projected shifts of this curve, this is 1 year, right? Next year, the curve will look different. Okay, so the median user next year maybe 2 gigabyte. And then if you project just 5 years down the road, you say, hey, even the median user will consume many gigabytes a month. And on LTE devices, it's nothing, right? It's just a single movie a month, and that's it, right? So this is one problem we just talked about. The second problem, however, even if you just stick with the same curve here this year, you see that the cost structure of ISP is not really driven by the median users, driven by the heavy users, the long tail of this distribution. And here you can see many, many gigabytes, okay, 5, 10, 20 or so gigabyte used a month. Okay. As soon as you start watching video on your mobile device consistently, then you are in the heavy usage. Okay. So if your company's cost is driven by these users and the revenue does not grow with them, then you are having a problem. So this is the second graph, the long tail reason why people are shifting, because the long tail is getting longer and heavier to the carriers. So they have to look ahead 5, 10 years and start thinking about it. And this is what started happening in the last 2 years in the US market. Now, what are the options to the carriers or the so-called internet service provider, in this case, cellular mobile ISPs? They do have quite a few choices. One is I can keep a buffet, I just raise the price. Okay, for example, if my buffet, I introduce a great new dish like unlimited lobster, okay, then maybe the price won't be $9.99, maybe $12.99. I can increase the price for everyone. But if you can do this a couple of times. If you keep doing this in the next 20 years and do it every other year, it's going to be a problem. Plus, we will soon see several reasons why it's also a very unfair and efficient way to do things. The second is, then I'll cap you. Okay, raise prices like in the dollar per total usage a month chart. It says that instead of charging you this, I'm going to charge you this. Okay, I increase the price, but you still get unlimited. Capping is another picture. It says that you can go up to this point, okay, whatever, 3, 5 gigabyte, and then you can't do it anymore. The price is infinite. You are prohibited from using it. The third way is usage-based. Okay, I give you up to a certain baseline, and then I'm going to start charging you with a slope. I can charge you actually with multiple slopes. Okay, either charge you more per unit as you consume more, or charge you less per unit as you consume more, or I can charge you based on long non-linear curve. But generally speaking, one straight line for practical and certain theoretical reasons tend to be good enough. And then I can throttle you, meaning that volume is unlimited, but the speed will be lower as you consume more. So if you are a bandwidth hogger, then I'll say, sorry, I can't let you enjoy the fastest speed. There are some downside to this, including litigation by certain users. So a fifth choice is I can offload from a congested network to a less congested network, for example, from 3G to Wi-Fi. Okay. Now, this is assuming two things. A, it's cheaper to provide Wi-Fi. Supply of capacity per dollar is much cheaper. Well, if you look at the access points, they are cheap. But to backhaul these traffic away, imagine you have a few access points. Okay, each of them is 802.11n. And they can support, say, 100 megabit per second. Okay, and got quite a few users coming out here. And then you need to port all these traffic through some Ethernet or other kind of backhaul. Who's going to support that backhaul expense? If you need to dig trench to do that, who's going to pay for that? Later in lecture 18, we'll devote a whole lecture to Wi-Fi, including air interface from access points to users and the backhauling issues. The second assumption is that not only it's cheap, it's also not so congested. So the performance is good. Now, of course, if you are moving fast, then Wi-Fi doesn't really support mobility very well. And furthermore, as you have experienced at airports or coffee shops and hotel lobbies, when there are just a few Wi-Fi users around you, your speed goes down quite a bit. Okay, so unless you're willing to pour in a lot of money, in which case the issue of capacity per dollar comes up again. Otherwise, Wi-Fi's expense and performance is not going to be unlimited supply. At some point, okay, Wi-Fi cannot support infinite amount of bandwidth needs. Okay, the sixth one is what we're going to talk about next lecture, lecture 12, smart data pricing. Now let's go back to compare flat rate, possibly higher price, with usage-based. Now, okay, the comparison between these two strategies is our focus today. Before going into any mathematical models, we first have to say, what are the considerations? One is economic viability. Okay. If the carriers do not see a healthy enough profit margin and revenue amount, then they'll say, I won't be doing it. Okay. Second, consumer choice. You have to ideally give consumers the ability to choose among carriers, among service plans, and also among their digital lifestyles. For example, asking light users, like your neighbor, to subsidize heavy users. That's a problematic proposition. Okay, it impacts fairness. Later in lecture 20, the last lecture, we'll have a whole lecture talking about different ways to quantify fairness. But intuitively, you see that, okay, if somebody decides to choose a lifestyle, that's their choice of consuming a lot, like watching YouTube on their iPhone along the commute for 3 hours a day every day. Why should I be paying for his choice? He's the one who's consuming the data. Why am I getting the bill? Okay. So this leads to 3 reasons why usage pricing in general is often a smarter idea than flat rate. Even though, as we saw, because of the underlying feasibility and the need to increase market share, before 2000 in the US broadband mobile market, usage pricing was not used. But now that the tide has shifted and usage pricing is here to stay, we also can see that whether you like $10 or not, maybe you think it should be $2 a gigabyte. Okay, we'll come back to the precise numerical value later, but the general concept of charging by how much you use has a certain advantages. One is it leads to less waste. 2 is that it doesn't force light users to pay heavy users' lifestyle. And 3, it leads to a more affordable differentiation of quality of service. We're going to explain these 3 reasons in 3 graphs later in this lecture. Now, before we go there, however, I want to very briefly highlight a discussion that's intertwined inevitably with any discussion of network access pricing. It's called network neutrality in the United States. This is a particularly sensitive subject. Part of the reason it is a challenging topic is because this phrase, network neutrality, is like the phrase happiness. It means different things to different people. You ask 10 people on the street what's network neutrality, you're going to get 12 different answers. If you ask 10 economists, you're going to get 100 answers. Okay. But in general, there are 3 different and in fact conflicting notions of neutrality here. The first set of notion is access or choice. It says that consumers should have access to different technologies and services and be given the choices. Okay, including the choice to pay more if they want a better service and the choice to pay less if they want to save money. The second ingredient often implied by neutrality is that there is sufficient competition in the marketplace such that no single provider, whether it's content or pipe provider, has a monopoly power in setting the prices. And the third one, which is itself a very confusing term, equality or no discrimination. Now you may wonder, equality and no discrimination in what? Well, one shade says that you cannot limit service. For example, you cannot ban Skype. Later in lecture 15, we'll spend a whole lecture on P2P technologies, including Skype and BitTorrent. So you can't say, well, because I want to generate voice revenue, even though nowadays AT&T Verizon realized that a voice and text you can have unlimited. Just give me back your unlimited data plan, right? But let's say they care about a voice, and suppose one carrier decides, say, no Skype, okay, because that competes against my own voice revenue stream, then this is not good, okay? Say this is not equality in providing access to services. Now, second potential meaning of equality is protocol-based discrimination should be banned. Okay, it says that, for example, Comcast, you cannot ban BitTorrent users just because they are using the BitTorrent P2P protocol. Well, it turns out that if Comcast or any provider decide to say, well, instead of banning against the type of protocol, I'm going to ban against very heavy usage, that's a different shade of gray. Okay? If so happens that heavy users are mostly using BitTorrent, well, then so be it. That wasn't my original reason. The reason is to say that some users consume too much, consume so much that it squeezes other users' quality. Then equality would say that, nope, you cannot differentiate consumer behaviors. Okay. You should treat all of them the same, even though they have different impact on each other and on your network. The fourth type of equality says there should be no traffic management. Okay, no differentiation of quality service. For example, they would say that to be neutral, a life-saving buttons signal should be given the same importance as online gamers traffic. Okay, so anytime you have quality of service, not neutral. Well, so if you look at these four different shades of gray of how neutral or what is neutrality in terms of equality of service, it's my personal bias that this makes sense. Okay, you shouldn't take choices away from consumers. This sometimes makes sense. Okay? You shouldn't discriminate just against a particular protocol. This I'm not so sure. Okay? Whether you should ban any differentiation of consumer behavior, because as we will see, if they are different kinds of behavior, they should be treated differently, perhaps. And this actually makes no sense. Okay? Let me be clear. It makes no sense to say no traffic management. Okay? This cross makes no sense. First, the internet has never been equal in treating all traffic. And second, it is very harmful to neutrality if you treat all traffic the same way. For example, consumer access and choice, which is, in my view, by far the most important view of neutrality, will be vetoed if you insist on equality of all the traffic. It is much more important to maintain access and choice than to go after this unrealistic notion that all packets ought to be treated exactly the same way. So, we have gone through a qualitative discussion of some of the factors behind pricing plans and net economy in general. Now, in order to go further, we have to do some math. We have to write down some quantitative models, and the one we'll be using is so-called a utility maximization. It should ring a bell to those who still remember lecture 2 and 3. Let me see, lecture 1 and 2, where we talked about payoffs in games, and the utility maximization can be viewed as a generalization of that in a networking context.